Hey, what's up? It's Jake from Nimbus DevOps, and I'm here today to talk to you about attribute shadowing. So, if we look at our namespace examples, we can see here I have some instance namespaces, I have some um, instance attributes, some class attributes, some things like that. We're going to make a new file to illustrate this, but when you search for an attribute, an object, if it's not found, Python extends the search to the attributes on the class that was used to create that object. And it keeps searching until it's either found or the end of the inheritance chain is reached. So let's take the woman example. So woman has an instance attribute of Jones. Let's say that I want to find the woman.species. So when I call this, the program's first going to go through the beginning of the instance inheritance chain. So the beginning of that is to look at the instance attributes. And it says, oh, I don't see species anywhere. So I'm going to go now to the class attributes. Oh, here's species. And it's going to return that. And if I had made Holly equals woman, and I had like Holly dot name or Holly dot uh, car equals, you know, a Tesla. Now you're starting to go down the chain of, okay, well, this is here. If I want to print a Holly.car, all of a sudden it's like, well, this is here. And this is just a gross estimation. This is like pseudocoding, right? So, like, I'm going to find this inside of Holly. Oh, it's not in here. Okay, is it in woman? No, it's not in woman. Like, oh, is it in speed? Like, it's just going to keep looking until it finds what it finds. And if it gets to the end, doesn't find it, it's going to be like, I don't know what you're talking about. So this is an interesting thing because it leads to a shadowing behavior. So let's look at attribute shadowing. So we're going to make a class called point. And in point, we will say x equals 10 and y equals 7. Then I will declare a variable p with a value of point, which is the class. So it's inheriting the class. And I'm going to print p.x and I'm going to print p.y. Okay, and that's simple. It should just print 10 and 7, right? So what if I say p.x equals 12? So p gets its own x attribute now because this is an instance attribute, right? So then if I said print p.x, it's going to find 12 here without going down into the class attributes to find x. So we're actually providing a value of 12 before it gets there. Okay. And if I had printed point.x, that would, the class attribute is still the same, would print 10, right? And then if I say I want to delete an instance attribute, I want to delete p.x, it's going to delete that. And if I print p.x after that, this should now be 10 because the search has to go again to find the class attribute. So it goes p.x. So there's no instance attribute x, so it goes into the class and then looks at the class attributes. Interesting little behavior there. If I had declared a p.z as 3, I could make a third point and print p.z, and it would print 3 as you would expect it to. But if I printed, this is kind of interesting. If I print point.z, what do you think happens? Let's see what happens. So let's call attribute shadowing. 10, 7, 12, 10, 10, 3. Oh, an error. Type object point has no attribute z. Now, why is that? Well, it's because this attribute is an instance attribute. And even though we're calling, like we defined it and all this other stuff, we're specifically calling the point class attribute z. We're not calling p.z and the inherited class from point. We're just directly calling the class, not the instance of the class. And the direct call of the class has no attribute z, but the instance of class named p, this namespace, does have a z attribute, and the value is 3. So that's why if I print pz, it prints 3, but if I print point z, there's no attribute z. So hopefully that makes sense. If you think putting x and y coordinates in a class attribute, if you think about that, do you think it was a good idea? What if we created another instance of point? Do you think that would help show why instance attributes can be useful? So when you think about it, like the first thing I think about is like default values, right? So sometimes when you create a class or a function or whatever, you might assign a default value, and then if something changes the values of variables inside of a class or attributes inside of a class or even in a function, that's something that could happen depending on how you've got your program scoped. But if a value is not provided, but there is a point for it, like in the case of point z, then it may be worthwhile to define some default values in case a value is not given. And that would be an example of an instance inheriting the attribute from a class to which it belongs, because maybe the instance itself does not have that attribute defined. So there are definitely examples where this is relevant and useful. But for now, this is just kind of theoretical, and I want to make sure you understand how this works and why it works before we start actually using these things and you start reading other people's code, so you can figure out how this works. And really, this is just scoping, right? This is just what is the scope of the attribute, and where are we getting stuff. So it's kind of like the same concept as scoping, um, with variables, except now we're talking about attributes in classes. So hopefully that makes sense. So yeah, as always, let me know if you have any questions, and if not, we'll move on to the self argument.